Bolt two surplus bomber jet engines onto an ordinary commuter rail car, and it should tear itself apart. Instead, it hit 184 miles an hour and set an American record that still stands today. For 60 years, engineers strapped jets, turbines, giant propellers, and magnets onto trains everyone was certain would fail. Some rode on a cushion of air. One never touched the rails at all. These are 10 train designs that looked utterly insane and actually worked.
Number 10. The GM Aerotrain.
In the mid-1950s, American passenger rail was bleeding money. Cars and airlines were stealing riders, and the railroads were losing hundreds of millions of dollars a year. So General Motors, the company that had already conquered the freight locomotive, decided it would save the passenger train too. Their answer was the Aérotrain, and it was one of the strangest-looking machines ever to ride the rails. Here's the part that sounds impossible. GM didn't really build railway coaches at all. To slash weight and cost, they took the aluminum bodies of their 40-foot intercity buses, added a strip up the middle to widen them, and rolled them onto two-axle carriages with airbag suspension. A conventional steel coach weighed around 65 tons. An Aérotrain coach weighed just 6. Up front sat a wildly futuristic locomotive styled by GM's automotive design legends Harley Earl and Chuck Jordan. Wraparound windshield, tail fins, headlights like a Cadillac, hiding a 1,200 horsepower EMD engine underneath. On paper, it was genius. GM claimed it could cut the cost per seat from over $2,000 to about $1,000. Two demonstrator train sets were built in 1955 and 1956 and loaned out across the country. The Pennsylvania, the New York Central, the Santa Fe, the Union Pacific. They racked up more than 600,000 miles. And it worked, technically. The trains ran. They carried passengers. They hit respectable speeds. The problem was the ride. Those light bus-bodied cars on two axles bounced and jarred so badly at speed that passengers hated it, and the locomotive was underpowered, needing helper engines to climb grades. No railroad bought a single set, but the Aérotrain didn't die. The Rock Island scooped up both demonstrators and ran them as Chicago commuter trains for a full decade until 1966. So the impossible spaceship on rails genuinely worked, just not the way GM dreamed. Both survive today in museums in Green Bay and St. Louis, gorgeous monuments to a future that never arrived. Number 9. The Soviet SVL. While the West chased high-speed rail, the Soviet Union refused to be left behind, and their solution was gloriously blunt. Take a standard ER-22 electric commuter carriage. Bolt two jet engines from a passenger airliner onto the roof. Point it down the track. See what happens. Built in 1970 at the Kalinin Carriage Works, this machine was officially called the SVL, the High-Speed Laboratory Rail Car. Its two engines were Evchenko AI-25 turbofans, the exact same engines that powered the Yakovlev Yak-40 regional jet. The wheels weren't used for propulsion at all. They just kept the thing on the rails while the jets shoved it forward. Engineers even fitted sleek nose and tail cones. The whole carriage was tested in a wind tunnel with 15 different scale models before it ever turned a wheel. The theoretical target was a staggering 360 kilometers per hour. In reality, the crew took it to 250 kilometers per hour, roughly 155 miles an hour, an astonishing speed for what was fundamentally a modified commuter car, tested on an ordinary line between Galutvin and Oziori. The plan, had it succeeded, was to use jet power to haul a future Soviet express service. The truly remarkable part of this story is the afterlife. The one and only SVL was simply abandoned. For decades, it sat rusting on a siding, jet cones intact, slowly becoming one of the eeriest pieces of engineering archaeology on Earth. A genuine jet train left to the weeds. It worked exactly as its builders hoped. The economics of the 20th century just didn't. Number 8. The M497 Black Beetle. Now, back to that hook. In 1966, the New York Central Railroad wanted to know one thing: could ordinary track handle extraordinary speed? Their engineer Don Wetzel had a beautifully reckless idea for finding out. The team took a Bud Rail diesel car, a bog standard self-propelled commuter rail car built back in 1953, and mounted two second-hand General Electric J47 jet engines on the roof. These weren't just any engines, they'd originally served as booster jets on the Convair B-36 Peacemaker, a Cold War intercontinental bomber. A designer added a streamlined black nose cone, and the press instantly christened it the Black Beetle. The whole thing was thrown together on a shoestring, reportedly around $35,000, and built in roughly 30 days. Then, on July 23, 1966, on a dead straight, otherwise unmodified stretch of track between Butler, Indiana, and Stryker, Ohio, they lit the jets. As a spotter plane flew ahead to keep the line clear, the Black Beetle screamed to 183.68 miles per hour, nearly 296 kilometers per hour. Wetzel later said the speedometer briefly touched 196 before he backed off. Sit with that number, because here's the impossible part. That 1966 run is still the fastest a train has ever gone on open track in the United States. Not Amtrak's Acela, not the Metroliner. Nothing built in the 60 years since has beaten a jet-powered commuter car from 1966. The railroad gathered priceless data on how track and equipment behave at extreme speed. But jet trains kicked ballast everywhere, guzzled fuel, and made no commercial sense. And the New York Central was about to merge into Penn Central. The Beetle's jet engines were pulled off and repurposed as a snowblower. The car itself was eventually scrapped in the 1980s. The design was a publicity stunt that outran every serious American train for the rest of the century. Number 7. The UAC TurboTrain. By the late 1960s, everyone had seen Japan's bullet train, and North America wanted in. But America and Canada had a problem. Hundreds of miles of old, curvy, freight-shared track. You couldn't just run fast on it. So the United Aircraft Corporation, an aircraft company, decided to build a train like an airplane instead. The TurboTrain, which entered service in 1968, was two impossible ideas at once. First, propulsion. Instead of a diesel or electric locomotive, it used aircraft-derived gas turbines, Pratt & Whitney ST6 shaft turbine engines, the same family that powered aircraft tucked into domed power cars at each end. Second, and even cleverer, the whole train could tilt. Using a pendulous suspension system, the cars leaned into curves like a motorcyclist, letting the train take bends faster without throwing passengers out of their seats. This was one of the very first tilting trains in North America, years before France's TGV and Britain's tilting trains, and it was genuinely, ferociously fast. Back on December 20, 1967, during testing on the Pennsylvania Railroad main line in New Jersey, a turbotrain hit 170.8 miles per hour, about 275 kilometers per hour. That remains the world speed record for a gas turbine-powered train to this day. So why aren't we all riding turbine trains? Reality on old track was brutal. Grade crossings, tight curves, and freight traffic meant service speeds were capped far below the design potential, often around 95 to 100 miles an hour. An hour into its very first Canadian demonstration run, a turbo train sliced clean through a meat truck whose driver tried to beat it across a crossing. Then the 1973 oil crisis quadrupled fuel prices and destroyed the turbine's one big advantage. Yet it worked, and it mattered. After early modifications, Canadian turbo trains ran reliably between Montreal and Toronto until 1982, with a documented availability rate above 97%. None were preserved. But their tilting DNA lives on in nearly every high-speed train that leans into a curve today. Number 6. The British APT. Britain faced the exact same curse as Canada. A Victorian rail network full of curves, and no money to build brand new dead straight lines like Japan or France. British Rail's answer was one of the most technically ambitious trains ever attempted, the Advanced Passenger Train, or APT, and it pushed active tilting further than anyone before it. The idea was elegant. If the track curves and you can't straighten it, tilt the train instead. The APT used accelerometers on each bogie to sense a curve and hydraulic jacks to actively bank the carriages, so passengers stayed comfortable while the train whipped through bends far faster than normal. The first version, the experimental APT-E, was powered by gas turbines and first ran in 1972. It was fast enough to set a new British rail speed record of 152.3 miles per hour in 1975. Then came the electric service prototype, the APT. In December 1979, it screamed up to 162.2 miles per hour, 261 kilometers per hour, a British rail speed record that would stand for 23 years, unbeaten until a Eurostar broke it in 2002. On paper, Britain had built one of the most advanced trains on Earth, and then it all went wrong in the most public way possible. When the APTP carried journalists on press runs in the early 1980s, the tilt system, combined with the motion of the curves, left some reporters feeling queasy and nauseous. The newspapers gleefully savaged it. Add persistent teething problems with the brakes and tilt mechanism, a decade of delays, and no political appetite to keep funding it, and the project was doomed. The prototypes ran a limited passenger service for barely a year before being quietly withdrawn. Here's why it belongs on this list, though. The APT wasn't really a failure, it was ahead of its time. The active tilt technology British engineers pioneered was later licensed, refined, and built into the Italian Pendolino, which eventually returned to those very same British tracks as the Virgin Pendolino, doing exactly what the APT promised decades earlier. The impossible train worked. Britain just gave up on it too soon. Number 5. The Aérotrain. Everything so far has kept its wheels on the rails. This one threw the wheels away entirely. In 1960s France, engineer Jean Bertin looked at the fundamental limit of trains, the friction between steel wheel and steel rail, and decided to eliminate it. His creation, the Aérotrain, was a hover train. It rode along a slim, inverted T-shaped concrete beam, floating on a cushion of air pumped out beneath it, like a hovercraft bolted to a monorail. With no wheels touching anything, the only real resistance left was the air itself. Bertin described it as an imprisoned airplane, flying without wings, tight to the ground. To test it, France built an astonishing 18-kilometer elevated concrete track near Orléans, raised 5 meters on pillars and running arrow straight across the countryside. The final prototype, the I-80, was driven by aircraft engines and a huge ducted propeller. On March 5, 1974, the upgraded I-80HV, fitted with a Pratt & Whitney turbofan, set a world speed record for an air cushion land vehicle, an average of 417.6 kilometers per hour and a peak of 430.4 kilometers per hour. That's over 267 miles per hour on a cushion of air in 1974. It worked. It genuinely, spectacularly worked. So what killed it? 2 things. First, it was deafeningly loud, and it required building an entirely new concrete network from scratch. You couldn't run it on a single meter of existing railway. Second, and fatally, France's national railway was quietly developing a rival, a train that used ordinary steel wheels on ordinary gauge track so it could run onto the existing network anywhere. That train was the TGV. In 1974, the government pulled its support and chose the TGV. Jean Bertin, exhausted and heartbroken, died the following year. His beautiful hover train never carried a fare-paying passenger, and the last surviving prototype was destroyed by an arson fire in 1992. But that elevated concrete track still stands near Orléans today, a 5-kilometer monument to a train that flew. Number 4. The Shinkansen Zero Series. Every train on this list owes something to this one. Because in 1964, most of the world's engineers flatly did not believe you could run trains at 200 kilometers per hour, all day, every day, safely on a schedule. Japan proved them wrong and reinvented rail travel forever. The Tokaido Shinkansen opened on October 1st, 1964, just days before the Tokyo Olympics, connecting Tokyo and Osaka. The first trains, the Zero Series, are the ones the world nicknamed the Bullet Train. That iconic snub-nosed white and blue shape, styled with an aerodynamic nose inspired by aircraft. And unlike everything else on this list, this wasn't a stunt or a prototype. It was a real, public mass transit service. To make it work, Japan didn't tinker with old track. They built something entirely new. A dedicated standard gauge line with no level crossings, gentle curves, and the world's first widespread use of automatic train control to manage safety at speed. The Zero Series cruised at 210 kilometers per hour, about 130 miles per hour, later raised to 220. The effect was seismic. A journey between Tokyo and Osaka, that took 6 hours and 40 minutes on the old line dropped to 4 hours, and later to just over 3. Suddenly, you could do business in both of Japan's biggest cities in a single day. The Shinkansen didn't just move people faster, it reshaped Japan's economy and daily life, and it did it with a safety record that stunned the world. What makes it impossible? At the time, high-speed rail was considered a dead end. Airlines and cars were the future, trains were the past. The Shinkansen single-handedly resurrected the entire concept and forced France, Germany, China, and eventually the whole planet to follow. The Zero series ran faithfully for 44 years, finally retiring in 2008. It didn't just work, it started everything. Number 3. The Shanghai Maglev. Everything up to now has, at some point, touched the ground. This one doesn't at all. The Shanghai Maglev, built on German Transrapid technology, developed by Siemens and ThyssenKrupp, is a magnetic levitation train, and it does something that sounds like pure science fiction. It hovers about a centimeter above its guideway on a controlled magnetic field, then is pushed along by a linear motor built into the track. No wheels, no axles, no contact, no rolling friction at all. The train literally flies down its own concrete rail. For decades, this was just a German test project, running on a 31-kilometer loop in Emsland, built in the 1980s. Everyone said commercial maglev was too expensive, too exotic, would never actually carry commuters. China called that bluff. Construction on the Shanghai line began in 2001, and regular commercial service opened in 2004, the world's first high-speed maglev in everyday operation. The route runs just over 30 kilometers, connecting a metro station on the edge of Shanghai to Pudong International Airport. And it is fast. For years, its top operational speed was 431 kilometers per hour, about 268 miles per hour, which made it by a wide margin the fastest passenger train in regular commercial service anywhere on Earth, a title it held from 2004 all the way to 2021. On a test run in late 2003, one of these trains touched 501 kilometers per hour. The whole airport trip takes around 8 minutes. Passengers watch the speedometer climb past 400 while the ride stays eerily smooth because nothing is rattling over rail joints. There are no rail joints, and nothing is touching anything. Is it a commercial triumph? That's debated. It's short, it was hugely expensive, and it hasn't been extended far. But as proof that a floating train can carry ordinary passengers day in and day out at aircraft approach speeds, the impossible maglev works, and you can buy a ticket and ride it right now. Number 2. The JR-Maglev MLX01. Shanghai's maglev is the fastest one you can ride. But Japan built one that goes faster than any train has any right to go, and it uses an even wilder version of the technology. While the German system uses ordinary electromagnets that pull the train up toward the track from about a centimeter away, Japan's design uses superconducting magnets, cooled to extreme cold, that produce fields powerful enough to levitate the train a full 10 centimeters clear of the guideway. That larger gap is what lets it survive truly ferocious speeds. This is the system tested for decades on the Yamanashi test line by Central Japan Railway. On December 2nd, 2003, a 3-car JR-Maglev MLX01 test train with a crew aboard was accelerated to an almost unbelievable 581 kilometers per hour, 361 miles per hour. To put that in perspective, that's faster than a World War II fighter plane at cruising speed, achieved by a train hovering 4 inches above the ground. It set a world record that stood for over a decade, and the engineers weren't just chasing a number. During earlier tests, 2 of these maglev trains were sent hurtling past each other in opposite directions, producing a combined relative passing speed of over 1,000 kilometers per hour. Imagine standing at the window as another train blurs past at a closing speed faster than many jet aircraft. Here's why this matters and why it's not just a stunt. Japan is actually building the real thing. The Chuo Shinkansen, a full commercial maglev line designed to link Tokyo, Nagoya, and Osaka, is under construction. A line that will eventually carry ordinary passengers at over 500 kilometers per hour through hundreds of kilometers of tunnel. The MLX01 was the impossible proof of concept. It floated, it flew, and it worked, and now it's becoming a railway. Number 1. the TGV V150. And so we come to the most improbable achievement of all, because the #1 train on this list didn't float, didn't use a jet, and didn't cheat physics with magnets. It did the single hardest thing imaginable. It took the same basic idea as a steam train from the 1800s, steel wheels rolling on steel rails, and pushed it to a speed that Maglev fans swore was flat-out impossible for a wheeled vehicle. France had already chosen wheels over hover trains back in the 1970s, and the TGV went into service in 1981, growing into one of the greatest high-speed networks on Earth. But in 2007, to celebrate that legacy, France decided to find the absolute ceiling of what a wheel-on-rail train could do. The project was called V150. The train itself was a monster of engineering. Engineers took a TGV and rebuilt it, 2 power cars sandwiching 3 double-decker duplex coaches packed with extra motorized bogies and pushing 19.6 megawatts, around 25,000 horsepower, more than double a normal TGV. They fitted larger wheels. They cranked the overhead line voltage up from 25,000 volts to 31,000. They chose a brand new, not yet opened section of the LGV Est line with a perfect gentle downhill profile, and they tensioned the overhead wire so the electrical wave in it could stay ahead of the train. Then, on April 3rd, 2007, with 3 drivers at the controls and a chase plane overhead relaying live pictures, the V150 accelerated for kilometer after kilometer and reached 574.8 kilometers per hour. That's 357.2 miles per hour. On steel wheels, in contact with the rails. At peak speed, those wheels were spinning at nearly 3,200 revolutions per minute, drawing enough power to light a small town. That record has never been broken. To this day, no wheeled train in the history of the world has gone faster. It sits there as the ultimate answer to everyone who ever said the old technology had hit its limit. A 200-year-old idea refined to perfection, doing something that looked completely impossible. And it worked. Some became museums. Some became the trains you can ride tomorrow. Which one blew your mind the most? Tell me in the comments. And if you'd ride the jet-powered Black Beetle, you're braver than me.